Okay, this is 2.6 homework help. The first problem gives us a rational function here, and it asks us for the horizontal asymptote, the vertical asymptote, and the x and y intercept. The horizontal asymptote, I have this information on the formula sheet. If you pull it up right here, I give you all the information you need about horizontal and vertical asymptotes. So feel free to read this over and use it if you need it. You get stuck. But basically, horizontal asymptotes, if the exponent is the same, the numerator and the denominator, then it's a ratio of the leading coefficients, which would be 2 to 1. So it would be y equals 2 over 1. The vertical asymptote occurs at zeros of the denominator, which would be 1, the x equals 1. The y-intercept is where x is 0, right? If you look at a graph, the y-intercept is where x is 0. So if you plug in 0 for x, you get negative 1 over negative 1, which is just 1. So 0, 1, the y-intercept is at 1 then. And the x-intercept is where y is 0, right? That's the point something comma 0. So plug in 0 for y and solve for x. You can multiply both sides by x minus 1. You basically want to know where the top is 0 then, because that's going to cancel. So add 1 to both sides and divide by 2, and you get x equals 1/2 for me. Okay, the next problem wants us to give the domain of this function. Actually, I'm going to answer the other questions before I give the domain then. Well, let's look at a graph of this thing first. If you graph it, you'll see that this function looks like this. It's got zeros at negative 2.25 and 2.5. But it also has, so let's enter those roots in then. The roots would be negative 2.25 and 2.5. It has one whole, so I'm going to factor the bottom. And the bottom in this case factors into, if you pull out an x, you'll have x squared minus 3x minus 28. And then if you simplify that, you can factor that into two linear factors, x minus 7 and x plus 4. So that helps us see where the function is undefined, so we can give the domain from there. Basically, we have undefined values at negative 4, 0, and 7. So those are the places where we have issues, either vertical asymptotes or holes. Negative infinity to negative 4 is the domain, then negative infinity to negative 4, as well as negative 4 to 0, as well as 0 to 7, as well as 7 to infinity. I know it's a lot to write, but we need to figure out where the hole is. And the best way to figure out where the hole is, keep in mind, holes are where factors cancel. So I don't know what the top factors into, but one of these factors is present in the top that's going to cancel and create a hole, whether it's x or x minus 7 or x plus 4. The best way to find it, in my opinion, is to graph just the numerator and find out where the 0 is. So it turns out to be negative 4. So what that means then is, in the top, one of the factors is x plus 4. If one of the zeros of the function in the numerator is negative 4, then one of the factors is x plus 4, which means that that factor cancels and creates a hole. So that hole is at the point negative 4, comma, and I don't know what they want for y, because negative 4 is undefined in the original function. So if you plug in negative 4, we know we get a 0 in the top, and we also know we get a 0 in the denominator, so 0 over 0 is undefined. I'm not sure what they want there. I tried some different things and didn't accept it, but I guess I'll try one more, undefined. And it's not seeming to accept that, so I'm not sure what they want there. But the vertical asymptotes occur at zeros of the denominator, so that would be 0 and 7. Don't include negative 4 because that's a hole. And then horizontal asymptote, since the exponent's the same, the top and the bottom, it's a ratio of the leading coefficient, which in this case is negative 8 over 1. Alright, I threw just a random algebra question dealing with complex fractions just to get us in the mindset, but we need a common denominator anytime we add fractions, so I'd start with the bottom and work up. This would become x plus 1 over x then right here. But I still have 1 plus that, and this is still 1 over that. And then I still have 1 over this whole thing and 1 plus that. So still pretty complicated here, but I can, instead of dividing by this fraction, I can multiply by the reciprocal, so I can flop this and make it x over x plus 1. then multiplied by the reciprocal. And then do the same thing here. I can make this 1 into x plus 1 over x plus 1. And this turns into then 1 plus 1 over, this would be 2x plus 1 over x plus 1. And instead of dividing by that, let's multiply by the reciprocal. So it would be x plus 1 over 2x plus 1 plus 1. And then once again, make this 1 a common denominator. So 2x plus 1 over 2x plus 1. And then you end up with 3x plus 1 over 2x plus 1. That's what they want us to enter in then. Oh, I'm sorry, this is 1 plus 1 is 2. That should have been 2 right there. And this would be A at the top, and bottom would be B. Next problem wants us to find the vertical asymptotes. Vertical asymptotes occur at zeros at the bottom, so we've got to try to factor this into linear factors if we can. We need two things that multiply to be -5 and add together to be 4. So that'd be x plus 5 and x minus 1. So the vertical asymptotes are at -5 and 1. Horizontal asymptotes, since the exponent's the same, the top and the bottom, then it's a fraction of the leading coefficients. In this case, it is -2, which you can see just back here. And then oblique asymptotes, there is none. There's only oblique asymptotes. This is on the formula sheet as well. If the exponent's higher in the top, then there's an end-behavior asymptote or oblique asymptote or a slant asymptote, different words for the same thing. But if the exponent's higher in the top, then there is this end-behavior asymptote. It looks like there might be one for this function, but there's not. So we'll talk more about that in class and in the notes as well. All right, I know this is a little hard to see, but we've got these 4 functions here. The easiest one is this 1 over x, the reciprocal function. We know what that looks like. That's b. All right, so 1 over x is b. If you make it negative, then it just flips over the x-axis, so then it'd be c right there. And then x squared, 1 over x squared is this function a right there, where it's just now the negative part of this original reciprocal function flips up because all those values get squared and they go positive. And then obviously if you reflect that over the x-axis, then you get the last choice, which is D. All right, next problem wants the vertical asymptotes. Once again, they occur at zeros at the bottom, so take each of these factors and set them equal to 0. Do that with the first one, -6x minus 6 equals 0, add 6, and then divide by 6, you get -1. And the other factor then, 9x minus 6 equals 0, add 6 to both sides, and divide by 9. And you get, that simplifies, 3 goes into 6 twice and goes into 9 3 times, so it simplifies to 2/3. Horizontal asymptotes then, these are, since it's the degree 2 in the top and the bottom, it's a fraction of the leading coefficients, but I don't know what the leading coefficients are, so I have to find them. So in the top, if I FOIL the first terms, I get 5x squared. And in the bottom, if I FOIL the first two terms, I get -54x squared. So the ratio leading coefficients would be -5 over 54. And then the x-intercepts. X-intercepts occur where y is 0. So you want to plug in 0 for y here. Plug in 0 for y and solve this, basically. That's where the numerator is 0. So that'd be 9. And it'd also be where this is 0, which would be 6/5 if you set that equal to 0. And then the y-intercepts occur where x is 0. Look at a graph. So plug in 0 for x. If you plug in 0 for x, you get -6 times 9 over -6 times -6, which is -54 over +36. So you don't need a graph for this. You can look at the graph, but it's going to be harder to get these answers from the graph than it is by hand using the information that's right here.